So, good day, my dear folks. So, I am just concluding in today's session the part 6 of my lecture Sanskrit or Sanskritam and Artificial Intelligence. So, I have established beyond doubt the superiority of the structure of Sanskritam language over English. I have told you about how we can generate these dhatus itself that are called Adideshika dhatus in my part 1 of my lecture, and where a single, if you take an example, a single Panini's Dhatu can itself create about 100,000 words, and 2,000 Panini's Dhatu is there that can create about 200 million words. 2,000 Panini's Dhatu can create 200 million words. All those things I clearly explained in my part 1. Therefore, it is an ever flowing natural language with minimum deviations which a computer would like. Now, what is actually meant to see? A computer only understands what is known as machine code, as I already told you, binary numbers 0, 1. And therefore, if you take a COBOL code, machine must be connected, converted into machine code. Therefore, using a compiler, we have a compiler, a product called something like a compiler, and then you run the program source through the compiler. The compiler first checks for any syntax errors, and then it is converted into machine language. That's a normal thing. Okay. And then we have the algorithms. Now, what are algorithms? Algorithms are nothing but a step-by-step, easy understandable language to a computer. See, first of all, in any computer programming, we have to have the logic and then the language. Logic must be very clear, how you split these words into a logic, and then the language. Logic is nothing but a power of the motion. It has to move forward, understand and move forward the machine. And then you have to language through which you express so that the idea of a motion is created. Now, how these things are done is what is known as through a computer binary code 0, 1 and 1, 0. I'll come to that. Now, what is actually meant by a logarithm for most of you is, it's a logic step by step. Suppose you want to make dosa, then you have to say, first step 1, you have to have rice, coarse rice. 2, grind it or powder it. 3, what grinder? Manual grinder with hand or machine grinder with electric current. Then 4th, make it into a powder. 5th, you have to say make it into a powder. You cannot simply leave it as it is. Then the 5th, you have to add water. Then the 6th, how many grams of powder plus how many grams of water you want, number of persons you want, average grams required per person, number of dosas a person will take. All these things are written step by step through a language. Then you code it. What we do, we use 0110 for rice, or 0101 for coarse grain or whatever, for coarse grain. Then 0001 for say water. Then grinder. See, we have what is known as source codes. Everywhere source codes are created. Whereas in English, I have already told you that you have to say that Chaitra goes to the village. Subject, the predicate and all must be there. Whereas in that is in English. Whereas in Sanskrit, I will simply say Gramam Gacchati Chaitra, and all those things I have explained. Therefore, the superiority of Sanskritam over English is well established. There is no question on that. We have even singularity, duality and plurality even for nouns and even for verbs. We have for what is known as Subandham and also for Tigandam. Subandhams are nouns and Tigandams for verbs. And we can go on creating. And I have already given you the example of Panini's Dhatu Gya, with which you go to the Subandha and add Gyasa, you will get Jigyasa. That is another Dhatu by itself. That is called Adideshika Dhatu. And then likewise, all these things are very clearly explained by me in my part 1 and part 2. And then I have already told you about the spirituality of Sanskritam language. Maybe some divine intervention is there in my part 5 of my speech. Therefore, what we have to do is the question. We all know that English is a tough language, but it is in force. You cannot defeat that. You cannot simply say, come on, throw away English and come back to Sanskrit. It is practically impossible, because the entire system has been devised and we are all using for generation now, probably about 100 years now. Example, programming languages based on the Latin alphabets, English. And then for the machine to understand, we are codifying. Everything is a Latin alphabet A, B, C, D written here and there, and English only, mainly in English only. But that does not mean Germans are not using their language, Germany, or the Chinese are not using Mandarin or Mongolian languages, Chinese, Japanese. So, but we are all used to English. That's why we say English cannot be substituted. Absolutely true. There cannot be any argument on that. So, my basic idea is what I would suggest even to the government, let us now design a compiler. Compiler is required, as I told you. Without a compiler, you cannot convert it into a machine code. So, a compiler should be created using the computer language based on Sanskritam. The entire Sanskritam we can feed now. Very well setup is there for all these dhatus and all these verbs, the nouns, the pratyas, the tvat pratyaya or nul pratyas, and the pradipadikams. Everything is today in modern days. Most of them are available on computers. All these Devanagari Lipi also are available. Therefore, design a compiler with a programming language based on Sanskrit. That is, have a computer which has Sanskritam only as a programming language. Now, that is step one. It's not very difficult. It's not that impossible. Very easy also. Now, step number two is what you should do is using Sanskritam. You write a program, minimum operating languages we say, or minimum operating systems. You can use minimum operating system using that compiler, which has already a Sanskritam based computer language, the entire system. Then on the step 3, you can define what is known as the micro operations for a computer based on computer language. Now, like I told you, gachati is, you can put a code word, present tense. It is a prathama purusha, third person, singular. You can put a code word for 0010, a machine language, a code, a binary code, and you codify it. Absolutely, you codify it just as what you have done in English. Now, with that code, when you operate a minimum, let us now test it. See, I am not sure 100% that the most efficient language is only Sanskritam. I am not here to declare that. But I know that Sanskritam will surpass English in a computer language. That much I am 100% certain. Now, to test that, let us have a system. See, we Indians are very good in computer programming, writing languages. Alan Turing or the Westerners invented computer, but that should be supported by a very good program writer. See, in film songs, you can have a very good lyrist. In Hindi film, for example, lyrist are Javed Akhtar or Gulzar, and the singers are Kishore Kumar, for example. But both of them should exist for the film song to be successful. Otherwise, if the lyrist simply writes his song and keeps it there, it will be there only inside the desk. There has to come a beautiful singer like Kishore Kumar and then sing it nicely so that it is a success totally. Likewise, we are good in computer program writing, like computer languages, in constructing sentences. There is absolutely no doubt. That is the asset for Indians, because by genes we have that. Because by genes, I would say Panini has taught us, when he has constructed our languages in such a way with dhatus. Every word you refer to my part 1 is derived from the dhatu, not an imported word like what in English has. In English has, like I told you, Kattumaram comes from the Tamil word, catamaran comes from the Tamil word Kattumaram. They have simply imported words like Pandit, Guru also they have imported. Everything is imported from Greek, from other languages also. But we have defined, there is no import at all of any word simply blindly. Everything comes from a dhatu. Every word comes from a dhatu, whether it is a noun or an adjective. In English, you will be surprised that you can be misled. See, for example, I am going to say every plural ends in S, and then I code like that in a computer programming language. It may be wrong. For example, class, C-L-A-S-S. It ends in S. Is it plural? No, it is singular. I have classes. Is it not? Similarly, in speech recognition therapy, I have a word called sentence. It ends in S, but it is singular. See, so in fish is another word which is singular and plural by itself. So everything I have to keep on defining, but such structures are not required for Samskrita. That's what I am saying. So we shall design a compiler, and then we shall write a program, minimum operating system, using Sanskritam as the programming language, and then we shall define every micro operating system based on Sanskritam. What is micro operating system? In computer we have registers. So when I transfer files from one register to the other register, I should use a language. So registers are created, and then each register I can add and multiply and deduct and delete or divide or subtract or whatever. These functions are there, varied functions are there. My special request would be for the government of India to first design a compiler based on a Sanskritam language, and then you have only on that, you have a specific project, something like radar, military radar. You can send a satellite outside using only Sanskritam language. Both of them communicate to each other in Sanskritam, so that jammers and anti-jammers for our other people, other nations to know, or to create an anti-jammer for our jammer signals will be very difficult if computer-based, Sanskritam-based programming languages are written. Because Sanskritam is in our genes. Sanskritam is there in Hindi, in Tamil, in Malayalam, in whatever national languages it is there. It's a fundamental. Everything we can understand. And we are skillful by genetic inheritance how to write a program. We are very skillful. That is no doubt on that. So we can try. The point is, there is trial costs nothing. And as I told you, as you progress further into deep science and deep technology, as a robotics, where speech recognition is also has to be there, then you should have a fundamental, a strong foundation of a scientific, well-structured, engineered language like Sanskritam, which I have explained to you in my part 1. That will help for us to proceed further future into high technology races without confusions. Of course, critics are arguing that for artificial intelligence, so much of a data computer knowledge based on English language is there, that the computer statistically generates its own prediction of hours. Prediction what you want by the availability of surplus input data through English. That's fine. I am not denying that. But there may be some other way that if you have a structured engineering language, not even Latin has conjugations for verbs. Latin does not have so much of conjugations for nouns. And Latin cannot create another dhatu, another fundamental. I have already told you how the word Vishnu, for example, is generated. Vish means presence. Vish is a dhatu. And Anu is a noun. It's a common noun. Anu and it is an atom. So a person present in every atom is Vishnu. That's how we derive. It's not simply imported. Likewise, once you have a very strong foundation of a scientifically engineered Sanskritam language as your fundamental basis, then the process of multiplier accelerator effect it can give to technology and the easiness in adopting over a long period, for a long period and for high technical skills, Sanskritam may be the apt one, which we have to try it out, and it is worth trying. See, that is my humble request. And on this basis, I am closing down my sixth portion, the sixth one, and the entire 6 portions of Sanskritam and artificial intelligence, and trust it can create or it can ignite a thought-provoking idea in new people. And if there is any, please give it on comments in my YouTube. And till such time, Bhuyat Tavat Shubhamangalam. Thank you.